moving on to the next one. The next one was the divergence. So let's talk about the divergence. I used orange, so I'm going to continue to use orange. What did we say divergence was? The spread, right? The spread of something. And we said divergence was del dot whatever function we have, E. And we know this is going to give us a scalar, like a number. We're going to get a number out of it. And we also know that this is a dot product. So I'm going to rewrite this again. Del dot E over volume is equal to so note, this is a volume integral. And this is a closed surface. We all understand what this means, right? It means it's a closed surface. Now, what do these both sides mean? So I'm going to do the left-hand side, and I'm going to do the right-hand side. This represents how much something is in that volume. And this represents the flow out through the surface. I'll explain. Imagine you have a balloon, and that balloon is filled up with water. What is holding the water in the balloon? The surface of the balloon? So the surface of the balloon contains whatever is inside the balloon. What if you puncture holes in the balloon? What will happen? Whatever is inside it will start to come out. Agreed? So the left-hand side of this equation represents how much something is in there. And the right-hand side represents the surface of the balloon, like whatever is coming out of the surface. Now, this mostly applies to electric and magnetic fields, right? So think about what an electric field is. So an electric field, you guys remember, for a positive charge, the electric field was coming out. And for a negative charge, the electric field goes in, correct? Good. So if you were to put a surface around this charge, it doesn't matter what kind of a surface it is, the amount of stuff that is coming out of the surface will be represented on the right-hand side. Got it? Whereas the amount of stuff that's making that thing will be on the left-hand side. So one integration will be over the volume and the other integration will be over the surface. And this is why when we were doing the cylinder and we were doing the sphere and we were doing all of those things, those integrations become very, very important. So on the left-hand side, how many integrals will we have in general? We're living on planet Earth. Very good. And then on the right-hand side, how many integrations should we have? Got it? So it's over the surface versus over the volume. Okay, that is called a divergence theorem. That is called the Gauss's theorem. That's also called the Green's theorem. Now, what if I put another thing in here that's also producing something? What increased? The amount of stuff coming out. And in physics, we call it the flux. So the right-hand side of this equation is also called flux. The amount of stuff coming out the surface. Out of the surface? Of the surface. And the flux is usually represented by phi, and we put a little subscript E, and that is nothing other than E dot dA, basically the right-hand side of this equation.